All right, welcome to Intro to Rigging. So I'm really happy to see some of you joining again, and that's Sophia, who I saw in Intro to Rigging, and very happy to meet new people who are Shantae, and I believe Hunter will also be joining this class. All right, so first and foremost, let's introduce ourselves. So I'll pass on a chance to talk to each one of you. And I want to know what is your main focus at Annam School. So whether you're studying rigging, animation, modeling, lighting, maybe something else. How would you describe your rigging experience? How many classes have you taken prior, rigging related or modeling related or animation, anything? And any other information that you want to tell us about you, like where you're from, where are you studying, or anything else. All right, so let's start with Shantae. By the way, I'm pronouncing it right, Shantae?
Yes, you are.
Okay.
All right. My main focus is modeling. I do have a little bit of, I guess, basic rigging experience. In my community college that I went to, we did animation classes. They had an animation 1 and animation 2 class, which was basically just like a broad thing of everything, like animating, modeling, rigging. So I got to experience like a little bit of rigging and skin texturing and doing the weights and stuff. Yeah, and I took classes in the community college as well as the introduction to modeling class and the intermediate modeling class here. And yeah, that's just about it. I'm from New York, and that's about it.
Very cool. So then why did you decide to take a rigging class as a modeler?
Well, it was required.
Oh, is it required at Annam School?
Is it? I figured it was because they said that you had to complete the first 3 and then go. And I also figured that it would be pretty interesting to get like a larger in-depth experience. And I think I read on the description that we would be doing something with blend shapes, which I thought would be pretty interesting to learn.
Nice. Yeah, those are all good reasons. I didn't know it was required for modelers, but I think it's a very good skill for modelers to have. First of all, because then you kind of understand better what your topology should be as a modeler. And as you said, so in some companies, they actually ask modelers to create blend shapes. So I think that's great. All right, thank you.
You're welcome.
All right, Hunter. Am I pronouncing it right too?
Yeah,
Hunter? Okay.
It's Hunter. Hello. But I suppose my main focus would be mostly modeling right now. I have some interest in it. I don't really have that much rigging experience. Like the most of what I've done was in a class I took in high school where we just did like a general animation sort of program, just kind of like in a variety of things, and then we had to figure out modeling our rigs to like use in our animation videos. Other than that, the only class I've taken was the Intro to Maya class, and they said that the other class for Intro to Modeling was full, so that's why I got moved to here. But I was still planning on taking it since, yeah, it is required, but it is a really good skill to have. I haven't really been studying too long. This is only my second term here, and that's pretty much it.
Nice, thank you. Yeah, to me, it's really cool to see that now, like as early as grade school, like high school, they teach some 3D concepts, 3D classes. I think that's really great. Like more and more, I see people who start working with 3D programs so early. I don't think I even used the computer when I was in high school. So very cool, very cool. All right, Sophia.
Hello again, Daria. Unfortunately, it looks like you got set with a match all modelers.
Oh, nice.
Yeah, but the Intro to Rigging is one of 3 that are required to go into the character track. So just so you know.
What are the other two?
The other ones are intro to modeling. It's intro to modeling, intro to rigging, and intermediate modeling, I think. Is that right?
It's the ZBrush one that the
Yeah. Intermediate modeling, yeah.
Or intro to ZBrush, I think.
I think it's dual titled. I don't know.
I forget it.
But then, so once you got those three, you move into the character program. So those three are the track, and then you graduate the track and you move into the program. But yeah.
Gotcha. Okay, thanks.
So
thanks for letting me know. Mm-hmm.
So my first term was with you, obviously. Second, I went into intro to modeling with Lewis Labrador. And now I'm back with you again. Hi.
Nice.
I'm glad they opened up another time slot for this because the other one was right in the middle of my work time. And I'm happy to see you again.
Gotcha. Yeah, I'm happy to see you as well. Nice. So you took intro to Maya, then intro to modeling, and now intro to rigging, right?
Yep. And so basically that means my only experience with rigging right now was the constraint rigging that we did in intro to Maya. So
gotcha.
But I'm excited to learn more though, because I feel like even as a skill or just for independent projects, like if I model something, being able to rig means that I can actually create like an independent project, even if I'm not working for a studio or something, and finish it. So yeah, I'm excited. Thank you.
Yeah, for sure. I agree here with you. I think it's definitely a very good skill to have for anyone, as you're saying, just to be able to have like this generalist experience, to be able to rig what you created. Yeah, I definitely agree there. All right. Well, thanks everyone for your introductions. So about me, let me introduce myself too. So I started working in the industry at around 2010. I don't even remember, it was either 2009 or 2010. So I have about 10 years of industry experience. And I've worked in a variety of industries. I worked in feature animation, visual effects, games, and in tech as well. So during my early years, I guess, I worked at the variety of various companies in the Bay Area in California. So most of them don't exist anymore, I don't think. So at all of these, I worked as a rigger, and at Tippett, I was not really technically working. I was kind of helping them out with a stop motion project. Okay, then between 2014 and 2015, I worked at Leica, which for those of you who don't know is the stop motion studio, and I worked on a movie. So when I started there, we were working on the box trolls, and then I worked on the Kubo and the Two Strings. And I started there working as a rigger, and then I transitioned into more of an engineering department that was writing tools for rigging, for animation, and for the 3D printing pipeline that they have. Then between 2016 and 2019, I worked at a robotics company, which also doesn't exist anymore. So I worked there for 3 years until they closed down. It was called Anki. And there was the first time where I fully worked as an engineer, and I was writing tools for animators to export their animation onto the robot that we were developing, actually on multiple different robots that we were developing. Okay, and now I work at a place called Unique. It's a New Zealand company, and I work remotely for them. So what they do is they create kind of realistic characters. Let me find an example. I should have probably thought of this earlier, but something like this. So it's characters like this. So I do some amount of rigging, but mostly I create tools for transferring animation, making sure that the characters work inside Unreal. So it's kind of exporting from Maya to Unreal, and also writing some rigging related tools. Okay, and since 2018, I've been working at Annam School, teaching different classes. So I've taught Intro to Maya, Intermediate Rigging, Advanced Rigging, Rigging Automation, and this is my first time teaching Intro to Rigging. And I'm really excited because I really like teaching. I found that I like a lot teaching kind of the intro classes. So the Intro to Maya class was great to teach. It was great to see people being excited, and also great to explain concepts that kind of I'm very familiar with in kind of a new light that makes me kind of understand new things about those familiar concepts myself. So that's been great, and all the other classes have been great too. Okay, so about this class. So you can find the syllabus online. Let's bring this up. So in your curriculum materials here, the first thing you will see will be the syllabus. So you can download it and open it up to see what we're going to be doing. So oftentimes when I start teaching a new class, I kind of change the syllabus a little bit, even if not officially, but in the way I teach it. Because of course every instructor have a different way of teaching, and we all have different ways in which we like to explain and like to understand concepts. However, this class, when I saw the syllabus and I started kind of preparing for the class, I really liked the way it's structured. So if there will be changes along the way, there will be very minuscule, but mostly we will go as the syllabus go. I think it explains all the concepts very nicely. So we'll be just following it the way it is here. All right. So in the first week, we will talk about, so this is today. Basically, we will talk about just rigging in general. We'll kind of introduce some concepts like hierarchies, nodes, different, the way objects exist in different spaces, and how objects transform. Then in week 2, we'll talk about controls, we'll talk about different tools. And so for the first assignment, we will work with this robot character. For the second one, we'll work with the Ferris wheel. Then week 3, will kind of, the complexity will increase. You'll have an assignment with this kind of pendulum clock. So we'll talk about more complex concepts. Then on week 4, we'll start talking about skinning. And talk about deformations. So we'll, for your assignment, you'll work with this kind of simplified worm character. And then after that, we'll start talking about rigging a biped character. So that's week 5 until the end. So that's going to be a lot of, actually a lot of information. So the class is very dense, but I think you will all enjoy it because it's really great. You can learn really great concepts, and there are very good applications for those concepts. There. All right. Okay, so that's the syllabus. Okay, so some requirements are, so I would like you to have a working microphone so that you could communicate with me. So if for some reason the microphone is not working, you can type in the chat, but that's a bit difficult because I might not see the messages in chat right away. So it's nice when people have a camera, just because if I'm talking just to an image, it's kind of weird. So yeah, so if you can have camera on, that would be a preferable situation. I don't care, by the way, if you like have to eat or I don't know, or if you're not in a very presentable state. I will never be in presentable state during this class probably, so I don't care how you look or what you're doing. It's just nice to kind of talk to a person instead of a square on the screen. Okay, another thing, please interrupt me as much as you want. You can interrupt me now, you can interrupt me when I'm explaining concepts. If I ask a question and you don't understand me, interrupt me then too, mid-sentence, mid-word. I think the great benefit of kind of doing online classes this way is that you can always kind of ask a question, so I will never be offended if you suddenly ask me something. I might lose my train of thought, but that's perfectly okay. I'd rather like explain something again and maybe get sidetracked, but make sure that everyone understands all the concepts and that everyone feels kind of engaged in the class. All right, and yeah, so ask questions as much as you need, as much as you want. I love getting questions from students because they make me myself kind of question familiar concepts, and also sometimes if I don't know the answer to the question, that's the best case because then I can go research something new and look up something new. Okay, and yeah, just whenever you want comments, like give me a comment on how the class is going for you. If something is unclear, if I'm going too slow or too fast or too boring, I don't know. You can always give me feedback about it. If you don't want to say it during the class, you can send me a message. I always appreciate that. Okay, so our class is going to be on Tuesday, 6:30 p.m. So usually the class is being split to a critique class and lecture class. But in this case, because we're only 3 people, we combine. So when there's 4 people or less, we combine the 2 classes into one. So on Tuesday, we will have both lecture and critique. Okay, so if you can't make it to the class, please send me a message through Annam School's website. There's a penalty for absent classes, but if you notify me, I won't count it as a penalty. So yeah, so just make sure to send a message if you can't make it. Sometimes I might not be able to make it to the class, and in that case, I'll definitely let you all know. I'll try to let you know as early as I can, and then we'll reschedule the class for a different time. Yeah, but hopefully it won't happen. Okay, so about rigging classes at Annam School. So this might not be as interesting to you guys since you're all modelers, but if, say, during this class you'll find a new love for rigging, you're also welcome to take intermediate rigging, advanced rigging. So these are the 2 next classes. And then there's rigging automation, which I think is one of the most useful classes there are, and not just for riggers, but for people of any discipline. So sometimes animators, modelers, lighters take it, and that's always great. So that's the class in which we learn programming and we learn how to write tools. So that's why it's so useful, not just for riggers, but for anyone, because you can write tools to, for example, automate your modeling tasks. So yeah, so after you take this class, you're more than welcome to take the rigging automation class.
What are the prerequisite classes for rigging automation?
I'm not sure, but so I have been teaching it for the past 2 years, and for me, the requirements are just that you take like either intro to rigging or intro to modeling, so that you know. So during that class, we write a tool throughout the whole year. and sorry, not throughout the whole year, throughout the whole term. And so it's good if you understand what kind of tool would you want to write. So that's why I prefer when people take some kind of intro class. So because then they get an idea of, oh, I do this thing like so many times, I want to automate it. So that's why. But other than that, so since you're just learning programming, like it doesn't really require anything. I think officially it might require intro to rigging, but for me, you can take it without taking any other classes.
Yeah,
Does
the
that answer
site
question?
itself says the intermediate rigging is a required.
Gotcha. Yeah, I don't know. I should actually I should talk to them about it. I don't think it should require intermediate rigging because it's good to take them either side by side or take rigging automation before intermediate rigging. And I actually remember I had students who haven't taken intermediate rigging but still took that class. So I know in my book it's okay. If any of you sign up for it without taking intermediate rigging, I'll be happy to see you. All right. Okay, so that's all the intro stuff. Any other questions before we go on? No. Okay. So rigging. So what is rigging? So the definition I came up with is that it's a process of setting up a character, providing an animator with control over its movement. And of course, there are many other ways of defining what rigging is. So character here is like taken in a loose sense because you can rig environment parts, you can rig props. So rigging is kind of a very broad spectrum of things. Okay, so to understand rigging, we kind of need to understand where does it fit into the pipeline. So if you think of a traditional animation pipeline, what kind of parts of pipeline can you guys think of? Now note them down. I guess if we are to work on a movie, where do we start?
Storyboards?
Sure. Yeah, so there is storyboard. And I would add here like concept art.
Yeah.
So all this kind of, I guess, visual development, could call it. Okay, so what goes next? If we have a character in a movie.
The modeling, I would suppose.
Yep. So we get a concept of a character, then we can model it. So what about after modeling?
Texturing.
Yeah, true. Let's put texturing here because texturing, well, let's put it here. Because texturing, you're right, it can go right after modeling. What next?
The rigging, I would suppose.
Yeah, exactly. Yeah. There.
Can I actually ask a question about the texturing with the rigging?
Yeah.
Sorry. So when you rig something, you got to keep in mind the way the textures would move, right?
Yeah. Yeah. True.
So wouldn't the texturing technically go before, or would they work concurrently to keep everything like looking nice as it bends, I suppose, or?
Yeah, good question. So you're right. Texturing should probably go here if we have kind of a more linear pipeline. In production, usually they kind of go side by side. You start rigging without textures being applied, and then the texture artist works kind of together, like parallel to you. But you're right. If we were to be one person, we would probably first model, then texture, and then we would do the rigging. Yeah, good note, good point. Okay, so after rigging, what do they have then?
The animation?
Yep, exactly. Now that we rigged the character, we can animate it. Okay, and after that?
Lighting?
Yeah, exactly. So then goes lighting, compositing, if we need compositing. And that's it on the visual, at least on the visual side. Then there's like music and sound effects and so on. Okay, so there. So yeah, so that's basically all the parts that you pointed out. So we have our rigging as an essential part between modeling and animation. And that's why I kind of like for us to think of how the pipeline is structured to understand where do we, as a rigging artist, where do we fit in the pipeline. All right, so rigging is a bit different depending on the medium that you're rigging in. So what kind of mediums do we have? So we have feature animation, we have visual effects, games, and I kind of broadly point out other mediums. So this is the project that I worked on. So just things that are not related to any of these three, kind of put in a separate category. In this case, it was just a physical object to which we're applying animation, but it had to be rigged in Maya before we can export this animation. Okay, and the reason why we're separating it by the medium is because rigging is pretty different for different productions. Maybe not in the beginning, but as you're getting more into it, trying to get more kind of complex things, the requirements will be different depending on your pipeline and depending on the industry you're in. Okay, so feature animation, the way it sort of originated was as a step after the 2D animation. So there's 2D feature animation and then 3D feature animation. And a lot of the same rules that 2D animators use, 3D animators use as well for the feature film. And you can often see in 2D animation, you will see very kind of unrealistic movement that kind of helps achieve appeal and helps achieve believability, even if it's not kind of scientifically accurate. So in this case, you can see as a scene from Dumbo, so the elephant is being lifted up, and of course, like for example, the way these ears move around, it's not anatomically even correct, but an animator would want to create that motion. So because of that, the rigs for feature animation usually need to do things that are not necessarily anatomically correct. So in this case, so these were, if you remember, they had these Looney Tunes 3D shorts. They made them to go before some Blue Sky movie. I don't remember which one. But the rigs they created for them were really great. They had a lot of features which were specific to kind of this stylized look, I guess. So you'll have a lot of kind of squashiness and stretchiness available for these kind of rigs. So there's a feature here to kind of get this effect of something moving quickly, the blur, this kind of blur effect, and things like that. So then for visual effects, all those kind of things take a secondary place. What is important in visual effects is to have a realistic rig. So that's why visual effects artists, the riggers who work on visual effects films, they spend a lot of time analyzing the motion of actual real life animals, making notes on how the muscle muscles work, for example. So muscle simulation is one thing that is very important for visual effects, but would be not important at all for feature animation. And even if we're talking about non-realistic creatures here, so for example, a dragon, it still needs to have the anatomy structure that is believable, so that the motion and the rig look so that they look like this creature could exist. Okay, now in games, it is performance is probably the most important thing. So if visual effects rigs or animation rigs can be really heavy, they can be heavy to load, heavy to work with. For games, they have to be pretty light. And those kind of requirements are going on the secondary place now, because just computers are much more powerful now than they used to be, so we can get away with having much more control in the rigs. So these days, rigs for games are actually much closer to what we have with, say, visual effects or animation rigs than what we used to have. Okay. However, with games, because performance is important, we need to think about kind of different ways on how we can simplify the rigs. And so one optimization that is being shown here is LOD, level of detail. So if when in the game you see a character kind of close to the camera or further away to the camera, usually we replace the model and we replace the rig. So making sure that all of that works and that the rig works for both a highly detailed character and for low detailed character. So all of that is the responsibility of a rigger. Okay, so then for other mediums, so these are two projects that I've worked on. So this is really, so this was from a movie Kubo, and it's really a feature animation film, so it kind of should go into feature animation. But because it was stop motion, it's like had completely set of different problems. And in this case, as I showed before, so it was kind of a physical robot, and we did all the rigging and animation in Maya, and then we exported that animation onto the robot. Right, so in stop motion, the way we do it, and both Leica and Aardman do it this way, and other companies then started doing it too, is we animate in 3D, we create a rig, we create model, rig, animation in Maya, and then we print out those faces, and then they're being kind of, with a magnet, they're being placed on the puppet and then replaced one by one. So it kind of takes its roots from the more traditional replacement animation, when someone would just sculpt by hand all the different expressions of the character, but now we can do it through 3D printing by creating it in CG first and then printing it out. Okay, so there are some challenges that come with it, and that's we can't have any parts intersect, so it's very important that all the magnets stay in place, that for example, so because there are often two parts, like the top part and the bottom part of the face, they obviously can't go one over the other. Thickness of the mesh is another important thing. It can't be too thin when the character deforms, because otherwise the light will shine through it, or it can also break. Okay, so this is an example from robotics, from the project I worked on, and it's so I believe it was the first project where something like this was used, but after that, I heard that it's now being also used like for animatronics. This technique is being used for animatronics and other similar things. And so the way it works is that we animate in Maya, then we export it to the format that we can convert to binary and place in a robot. In this case, just all the data from Maya is being written as a JSON file. And then that way we can control a robot's movement. And there are many, many challenges that come with something like that. One example is that the movement is different on different surfaces, so we kind of have to account for that. Okay, so any questions about kind of different mediums and how to work with rigs in different? No, okay, good. So now when you're starting to rig, one useful thing you can do is analyze some existing rigs. And at Anim School, you have access to Malcolm rig. So on the website, you will see it on the website. There are sets and props, simple rigs, advanced rigs, and in advanced rigs, you can get Malcolm 2.0. Some students told me that depending on the class you take, there are some rigs you can't use, but I think this rig is available for everyone. So you can definitely download it and check how it works. It can be very useful to kind of try and pose the character. So this can both give you an idea of how an animator would use your rig and also give you an idea of, oh, how is it structured? Maybe I can do something like that too, kind of thing. Okay, so now I want to start with some kind of rigging concepts that are important to understand. So one of them is nodes and attributes inside Maya. So it's something we often don't think about it when we start kind of using Maya and creating things, but anything that exists in the Maya scene, anything we create, is actually a node. And if you even create just one object, it will often be multiple nodes. So under the hood, you can always, you can open what is called a node editor. We'll look at it in Maya in a bit. And you can see all the different nodes and how they are connected to each other. So there are multiple types of nodes. The ones that we are going to be looking at, the main ones are a transform node. So all the objects, so say like a polygon, a mesh, a NURBS, a circle, a group, a locator, those are all transform nodes. Then we have shape nodes. So the shape of an object that you see is a shape node. And then utility nodes are very useful for rigging. Those are the kind of math nodes that we can use to kind of calculate numbers. Okay, so if, let's actually see that in Maya instead of the images that I draw. So if, let's say, we decide to create a cube, so we press a button to create this cube. So what we see in the outliner is that we created an object called pcube1. But if we are to check the nodes that got created, we can go to Windows, and then there you will see Node Editor. Open it up, and you can see another node here, pcube shape1. And if you are to press this button to check connections of pcube1, you will see a third node here too. So this node, we didn't create, it existed here before. So this is a render node that kind of renders the whole scene. But in reality, when we create even a cube, these three nodes get created. So this is the transform node that we select when we select the cube itself. So if you select the cube in the scene, it's this node that we're selecting, the transform node. So how can you find what it is? Well, you go here and you can see it says mesh. So you would go, actually, so this is the shape. So you would go here to pcube1 and it says transform. Then, so it creates also this polycube 1 and pcube1 shape. So if you select pcube1 shape, it says mesh. So mesh, you might say, well, mesh is not a it's not a shape. Daria, you told us it will be a shape node. So mesh actually is a shape node, or rather it inherits from a shape node. So nodes can inherit one from another, and that means they take the functionality of their parent and they take the attributes of the parent as well. And then the third node that we get is this creation node. So you see it's called polycube, and that inherits from the node that is responsible for creation of objects. So the reason why it's important is that if, say, you might have noticed that when you create, where is my channel box? There it is. Let's put it back here. Okay, so when you are creating an object, you probably noticed yourself that the first thing you can do is go into the inputs and change its, say, width and depth and height. But you also can change those things through these attributes, through, say, scale, rotation, translation, and so on. Well, for these things, you would change them through scale. So you might ask, why do we have this kind of repetition, and why do we have two ways of doing the same thing? Well, that's because we are changing different nodes here. So in this case, if we're changing parameters here, we're actually changing this polycube 1 creation node. And if we're changing values here, then we're actually changing our transform node. Okay, does this make sense so far? All right, let's go back. Okay, so these three nodes get created, and they all do different things, and they're responsible for different things. So transform node is responsible for how we can move an object, how we can rotate it, what can we do with it. The shape node is responsible for what the object is. So in case of a cube, it will be the vertex position. If we create, say, a NURBS circle, the shape node is going to be responsible for those control points that we can move around. So what that means is that if we are to change, say, the vertices of this cube, we're changing the shape node, but we're not changing the transform node. And yeah, and this example we already saw. So in right now, if we're to move it somewhere, we change 3 different nodes. So we change the shape node when we move the vertices. We change the creation node in the beginning when we change those values. And we change this transform node by moving it. Okay.
So when you use the freeze transform tool on the modeling shelf, what that does is it only affects the transform node and not the shape node. Is that how that works?
Yeah, that's what I would assume. I actually don't know what exactly the freeze transformation does under the hood. It's a good question. Let me make a note of that to check later. But yes, so what I assume is that it only modifies the transform node. Okay. All right. So now attributes. So attributes are specific to nodes. So different nodes can have different attributes, and they're responsible for the input we have to the node and the output from the node. So in this case, we're looking at 2 cubes in the node editor. Oops. And we can look at them in Maya as well. So here we have p cube 1. If we create another one, it would be p cube 2. So we can clear the node editor by pressing this clear button, and we can add objects by pressing this button, the one with the plus sign that adds the objects we have selected. So if we check these objects, you will see, well, you can obviously see the attributes here in the channel box, but you can also see way more attributes in the node editor. And that's because some of these attributes are only outputs and they're not keyable attributes, so they don't display them in the channel box. So in the node editor, you can kind of collapse the node by pressing these buttons, or you can expand them by pressing the same ones. So that way you can kind of control how much of the node you see. And you can also connect different attributes with each other. So when you're connecting, you need to make sure that you're connecting the output with the input. So some attributes only have the output, like these ones. And some attributes have both input and output, are responsible for both input and output of the node. And some of them are responsible only for input. So we can connect different attributes with each other. So here, for instance, we can connect translation y of the 2 cubes. And we can do that by just dragging it from one to another. So you can see it creates this arrow. It means that this cube's translate y output is being fed into this cube's translate y input. And you can see what that did is it turned this attribute to yellow. So now, if we move this p cube 2 up, the p cube 1 will follow it because their attributes is connected. One attribute is controlling the other one. But it's done in a very simple way. And when it's done in a simple way, it also means it's done in a light way because we just have the data from the output being fed to the input. So it's kind of the same thing as if every frame we were to insert that number here ourselves. Okay, everything clear so far? Any questions? Okay, good.
You were doing that from the transform node, right?
Yes, exactly. Mm-hmm. Yeah, but we can connect attributes of any nodes. We can connect attributes of shape nodes and so on. Okay, so if you're curious to find out more about nodes, you don't have to, especially for this class. But if for some reason you're curious to learn more about them, Maya has a node reference, and you can get to it by going to help, scripting reference there, Maya scripting reference, node and attributes reference. And here, all nodes that are possible to create in Maya, you can find them here. And it can be useful if, for example, you see something like, what was it? That creation node. So we can go to attribute editor and see it's called polycube. And let's say we want to know what does polycube mean. Or here, for example, we want to know what does mesh mean. So we can go into, where was it? There. Into here. And we can type polycube. And there it is. So we can read about what it does. So this node creates a polygonal cube according to the width, height, depth, and number of subdivisions. That's how we know that this node is responsible for creation of this cube. Okay, the rest information is more important if you're scripting, but you can still look over what the different attributes of this node are. And here also, it shows what is the parent of this node. So in this case, it's polyprimitive. So if you go to polyprimitive, it says a base node for polygonal primitive nodes. So that means that the polycube is polyprimitive, so it inherits from it. And that inherits from polycreator, which is responsible for creating all the polygons. Okay. So that's nodes and attributes. So now hierarchy. So hierarchy is another important concept to understand. So so far, we looked at the way we can connect to objects through connecting their attributes. But you can also change the way different nodes behave through placing them differently in the hierarchy. So you can parent objects to one another, and you can unparent them from one another to control how they are in the hierarchy. So in this case, let's remove that connection. So we can remove the connection we created. One way would be through deleting it. So here we have this connection. We can just click on it and click away. So that will delete it. We could also break this connection by right-clicking on the attribute and say break connection. Okay, so now if we parent pcube2 under pcube1, if we move pcube1 around, pcube2 will be following. So that's something that's computationally is a very light thing to do. So that's why if your rig has like this kind of structure, it will be a pretty light. It will be a pretty light rig. All right. So now, oh yeah. So how do you parent? So one way of parenting is by just pressing P. So that's what I did here. So you can click on one object, shift click on another, press P, and this object will be following this one. Then you can press shift P, and that will unparent them. You can also change the hierarchy in the outliner. So you can middle mouse drag one object underneath another, and that will achieve the same effect. Okay. And yeah, and also with parenting, so we can move this child object as we want. It won't affect the parent. Also, if we rotate the parent, the child will rotate from this point. And if we scale the parent, the child will both scale, and it will also kind of translate with this object, right? So this child moved. Visually, I mean translate. Okay. So now, an important concept also in rigging is what is the space of an object? And there are multiple spaces. So there's world, object, parent, gimbal, so on. The two most important ones are world and object. And you can notice it if you say have an object selected and has a certain rotation, you can go into tool settings, and you can see when we're in an object mode, the manipulator points to the way the object is rotated. If we are in world space, then the manipulator will be positioned as it is in the world. So you can see this is the world orientation, and it will show the same thing. So that can be useful for both animators and riggers. So if, say, animator wants to move something along its axis, along the way the object is oriented, they can do that. But then if they don't, they can choose world and move it like this. So this can be kind of dangerous for an animator, because you can notice if we are in object mode and we decide to move this object, only one parameter will change. Oh no, two of them change. Yeah, let's put it to 0. It's unparented. Yeah, I'm not sure. So Zine does fine. $45. Then we move it like so. Yeah, I'm not sure why both of them move. I thought it would be just one of the axes that would be moving. But an interesting thing here is that if we do it in a world and we try moving it by an axis, yes, this is not what I expected. So just X moves, just Y moves, just Z moves. Should be the other way around. Okay, I'll have to look into this again. But usually, kind of object mode, your object mode is going to be more accurate. Not in this case for some reason. So I'll look into why. So you should usually animate an object mode, but in this case, I guess, well, okay, let's try rotation. So in this case, if we rotate, for example, on Y, just the Y is being rotated. But then if we change it to world and we rotate, then all the axes are rotated. So I guess that's mostly important to know for rotation. So with rotation, it's important to rotate in object mode, because if animator will rotate one axis and all the 3 attributes move, then it's like more work for them than in the graph editor to work around that. Okay. So any questions so far? All right. So different spaces. Okay, so I have a question for you here. So let's say we have 2 objects that are positioned at the same point in space, with second one being a child of the first, and the translation, translate Y attribute of the parent is 5. So my question is, what is the translation Y of the child? Does the question make sense? What do you guys think?
Would the child's attribute remain at 0, and then if you unparent it, would it go back to where it was before? Or would it change with it?
Yes, so that's a good question. So that's kind of the main question here, right? So does the child, so if we translate an object and it has a child, does the child translation also change, or does it not? So to understand that, it's important to understand the concept of the space. So because, okay, so let's try doing this. So we say translate this object 5 up. So then we have another object. Let's make it a bit bigger so that we can see this better. So right now, this object's translation y is also 5, right? So the question is, what would happen if we parent this one to this one? Would this turn to 0, right? Or would it remain 5?
Doesn't that depend on, like, if you parented it at the world source and then moved the parent 5 up with the child following, wouldn't the child remain at the world source versus, like, if you parent them both at 5 up, wouldn't it stay at 5 then? Like, wouldn't the child stay as it is?
Well, let's see. Let's try parenting it and see. So if we do this, you can see that the child does just stays at 0. So it actually doesn't matter if we translate them together or if we parent them afterwards. So it will still change its value to 0 because all the translations we see are dependent on the parent. So they're in the parent space. Does that make sense? So your first guess was correct, and then you started second guessing yourself. Okay, let me turn on the light. All right. So let's go here. Okay, so it's the answer. All right, and so that's an important thing to understand because it will be the same with rotation. It will be the same with any kind of attribute. And when we're talking about rotation, it can be pretty handy in case we want a child object to have no attributes, no values in the attributes, but we still want it to be oriented in a certain direction. So let me demonstrate it here. So if right now we take p cubed 2 and we rotate it, say 45 degrees, and let's go into object mode. So you can see this object is now oriented this way. So now if, say, we want to rotate it around itself, we can easily do it with just changing one attribute, or if we want to rotate it around itself like this. But we couldn't give p cubed 2 for animator to set keyframes on because these are non-zero values. So we can create this p cubed 3 object that has no values here, but we can still rotate it in the same manner. So we can still rotate it around itself and this way and this way. So this can be pretty handy for rigging. So we will often will be, say, grouping an object so that it doesn't have any values, any transform values, but it can still be rotated in along the axes that we need. Does that make sense? Okay, and it will probably be clearer when we do rigging for the character. All right. So now a pivot point of an object. So if we select any object and we press W to show the manipulator, it will also show you where the pivot point of an object is. And by default, it's at center. But we can change it if we want. And we can change it by holding D and moving it. Or you can press Insert and also move it. And one thing that can be handy is that you can also snap it to places. So if you hold D and you hold V, then you can snap it, for example, to this corner of the cube. So if, for example, you want to rotate this cube from its corner, you can change the pivot point to be here. And you can also, what also can be handy is snapping it to the grid. So say if we snap it here, now it will rotate from the origin. Okay, and then another feature that can be useful, which is actually something Sophia found, was that we can match two pivots together. So if we select two objects and go to modify, match transformation, match pivots, they will become the same. So this can be handy if you need to, for example, group an object and then make sure that the two pivot points of the group and of the object are the same. So that's one example. And then you can also center the pivots. So right now, they're both centered, but if, say, we have this pivot somewhere here, you can go to Modify and click Center Pivot, and it goes to the center. Okay, so that's those notes here. All right, so now grouping objects. So one reason to group objects can be to just have all objects under the same parent. Another reason can be kind of similar to changing a pivot point. So you can have your group positioned at a different place from an object and then rotate, say, or translate an object by kind of grabbing that group. So that can be useful things. So also groups are very light and they're just an empty transform node. So if, for example, a polygon cube is a transform node, a shape node, a creation node, a group is just a transform node. So it's better to parent under the group than say under a locator or something else if you're concerned about the performance of your rig. And there's a shortcut to group something, and that's Control-G. So if, say, we select this cube and press Control-G, it creates a group around it. And by default, the group is going to be at the origin. So if we are now to rotate this group, you can see it's as if we are rotating this object from an origin. And we can obviously group multiple objects, so we can place multiple objects underneath the group and rotate and translate them from here. Any questions about any of this? Okay, hopefully, so most of these concepts should be familiar to you guys, especially after modeling. Okay, so then that's it for the lecture. So then the assignment, and we'll look over a bit how you would approach it. So your first assignment is to get this model of a robot from the website. So in the materials, you will see there will be a download option. So you want to open the robot up and connect different parts of it together. So change the hierarchy. So right now, this is just all objects together under the group. So you want to change the hierarchy in a way that makes sense. So in the way where the robot can be easily posed. Okay, so then the third part is to pose the robot. So after you create all the hierarchy, you want to pose your character, take a screenshot, and take a screenshot of a character in a pose. So then the fourth part is you want to make a video that shows how the robot is built and how it works. So you want to move every part of it. You can pose it as you're doing the video. So that will kind of demonstrate your hierarchy. And you want to submit multiple files. So you will submit the robot Maya file, either MA or binary. Either one is fine. Binary is probably better for this class because then we can then it will be quicker for me to download. You want to submit an image, and you want to submit a video. So I will be grading based on 3 of those things. So there are some extra credits. So first one is to make sure that the robot's hand can be rotated kind of this way. So if we rotate, when we rotate all the fingers, they should all kind of go out, and if we rotate them back, then they will kind of all go in. So I won't show you how exactly to do that, but you can figure it out based on the concepts that we talked about today. Okay. And then the second also extra credit, you don't have to do it, is you can get the Malcolm rig from Adam School, pose it in a pose that looks good, appealing, that is readable, and upload a screenshot of that pose. Okay, do these make sense? All right, so now let's take a look at the robot, and I'll kind of walk you through how you would approach working with such character. Okay, so I downloaded it earlier. So you probably want to actually open it, not drag it in. Yeah, so dragging a file in would import it, and opening it actually opens the file itself. So I will do that. So you can see right now, it's just a group with all of these meshes. So if an animator tries to animate it, they can't, because everything pivots from the origin. So if they want to move this body, they kind of have to move it from here. They can't really rotate this leg. So you want to change the pivot points, and you want to reparent them so that, say, if they grab the body and move it around, everything else follows it. Or when they, say, rotate the hand, the arm, the rest of the arm also follows. So let's look at how you would do that on an example of an arm. So first, what you want to do is you want to change the pivot point. So as we remember, we can press D and we can move it around. But in this way, it's difficult to move it so that it's exactly in the center of this ball. I guess actually before we even start moving, we want to think about how this character would move. So we can think of what the hierarchy is going to be. So let's say we're thinking, okay, so the main part is going to be this body. So everything else is going to be parented to it. So then the head will be kind of the second part, and also these will be kind of on the second hierarchy level, and this part will be on the third level, right? So this will be parented under this, which will be then parented under this. So we can kind of decide how the hierarchy is going to be, and then where everything will be rotated from. And for some parts, it might not be a straightforward answer. For example, from the body, you might want to rotate it from here, from the very bottom, or you might want to rotate it from the center. You might also have an option where you can do both. So you can think about how to do that. For an arm, however, it's pretty clear that it should rotate probably from the center of the sphere. And the way you can decide that is by thinking, well, how would this robot's arm rotate? And then you can think, well, how does my arm rotate? Well, it rotates somewhere from here, so it hinges on here. So if we are to build this robot physically, we would rotate this sphere starting from here. So the center of the sphere is kind of difficult to find just manually. So how do I stop this? There. So one trick you can use is placing a cluster in the mesh. So a cluster is a deformer, and we'll talk later about what they do. I'm not even sure if it's part of this class. You might be talking about clusters only starting from intermediate rigging. But what it can help us with here is finding a center of selection. So the one great thing about clusters is that automatically they're being placed in the center of, how do I remove my zoom? There we go. Okay, so automatically clusters are being placed in the center of whatever you selected. So if we say select this ring of vertices, and we go to rigging, deform cluster, it places a cluster right in the center of that ring. And in our case, it's the center of the sphere as well. So now, if we want, we can snap the pivot of this object to this cluster. And I'm going to put this object on a layer so that, and put it in a template mode so that I don't accidentally snap to the geometry. So now I'm holding D, I'm holding V, and I'm snapping to this cluster. And I'm only using this cluster to find the center of the mesh. So once I snapped this pivot, I can delete this cluster handle. And you can find it in the outliner, or you can select it here. But as a result, we have our pivot where we wanted it to be. So now we can rotate this arm, and it rotates in a very natural way, because the way this robot is structured is that there is the socket and there is the ball that fits into it. So now that we did that, we can go down the hierarchy, and we can now change the pivots of this arm. So again, so we can first maybe even make this invisible so that we can only work with this object. So again, we can use our clustering trick. We can select the top, select the bottom vertex, and create cluster. And in this case, I just press G to create it, because so G is a shortcut for repeating the last command. Okay, so now that the cluster is here, I'll do the same thing. I'll put this object on the layer. And oops, by holding D and holding V, I'll snap it to this cluster. Work? No. Oops. Okay. So now that worked, and now you can see we can rotate again the second part of the arm now. And animator can also wiggle it a bit here if they want. This would be not a possible motion. So if we're actually creating a rig, at the end we would probably freeze, we would lock and hide these attributes. For this assignment though, you don't have to do it. Okay, so now we can delete this cluster, and now parent this forearm to the shoulder. So if we select it, we then select the top part, we press P, and now they're parented. So now we can move this arm around, and we can also move this part in the way that we want. And now we can easily pose the arm. So a good test for if everything is working is trying to place it in different poses. And as you're working on it, you can do the same thing for all of all the parts. So the principle will be exactly the same. Okay, any questions? No, all right. So in that case, we're done with 10 minutes to spare. That's great result. So yeah, sometimes we'll be ending class a little bit earlier, sometimes a little bit later. We'll see how it all ends up. All right, so once again, a reminder, we don't have a class on Saturday, just on Tuesdays. So you don't have to come in on Saturday. And so the assignment is also due next Tuesday. So just make sure to upload it into the week 1 slot. All right, and in that case, I wish you a good night, and I'll see you next week. Bye, everyone.
Night.